All right, welcome to Abear's LeetCode extravaganza. Today we're going to be working on another problem, number 359, one of the premium problems, logger rate limiter. This is part of the Microsoft top interview questions, so we're going to just dive right in. We'll be working in Java today, as always. It's my preferred language. Let's summarize the problem quickly and we'll hop in. Design a logging system that handles a stream of unique messages along with their timestamps. A message should only be printed at most every 10 seconds, and all the messages come in chronological order. Several may have the same timestamp. We'll go over the example here. This would be the input. You have 1 as the timestamp, foo, 2 bar, 3 foo, 8 bar, 10 foo, 11 foo. So it should be true, true, false, 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 true. True, true, false, 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 true. All right, let's get started. So we know that we need a data structure to hold a set of unique strings, the messages, and their corresponding timestamps. That is a hash table. So we're going to go ahead and create that. A hash map, I should say. I'm at logs. And now one part of the problem, we'll go down here. In the constraints, I didn't really go over this. You can see that at most 10 to the 4 calls will be made should print message. What that means to me is that I should just try to make this efficient in terms of memory and space. Now a hash map is going to grow in size as you continue to put objects in it. So think about the fact that maybe you are putting objects in and they've expired. It's already 10 seconds, 15 seconds past. Whenever you're doing a lookup, it's now going to have to sift through that hash map and find that value. So we're going to want to trim the hash map as we go through. And we can do that with a queue. And so with this queue, what we're going to do is we're going to maintain the active log entries that are within that 10-second time limit, and then we'll be removing them as they expire. And we'll remove them from the hash map as well. All right, so we've created a hash map to hold the logs and the queue to hold the active log entries within 10 seconds. So now, whenever we call this should print message, we need to actually get to the meat of the problem. So first, we're going to purge the queue and the hash map for all expired log entries, messages and their timestamps. So while the queue is not empty, and since a queue is a first in, first out structure, that means the oldest entry would be the one on the top. So now we have the oldest one. What we're going to do is check and see if the logs contain the entry, and if the logs entry is expired, aka plus 10 seconds is less than or equal to the timestamp, then we're going to remove it from both the queue and the log. So remove it from the queue. And remove it from the logs. And now if it is not inside the queue or if it's not inside the queue in this time frame, then it's currently active. So what we will do right there is we'll just break okay. Um, and now we've finished processing the log. So now we can process it. So pretty much the same logic. If the logs do not contain the key, or the logs message timestamp plus 10 is less than or equal to the timestamp, then we're going to add this entry. And then return true. Otherwise, return false, as we do not need to send this. Should be able to run this. Hopefully I don't have an error here. Oh, somehow deleted one class in here. Gave me a weird start to that. Some syntax here. All right. And we are successful. We beat 74% of the memory complexity, and runtime, it's 6.29, 11.01. Seems like it's bouncing around. So yeah, sorry about this section here. I don't really know what's going on. Seems like LeetCode kind of popped me into a weird class. I'm gonna start a topic. But that's basically the problem. So the main thing to note is that when you're working with queues or hash maps, if you want to maintain the size, you want to be trimming that hash map and monitoring its size and making sure there's not unneeded elements in there. Because every time that you access this element or this hash map to get an element, it's going to have to perform a lot of overhead maintenance in terms of creating the hash and managing the table and accesses. So the smaller it is, the better it is. And you can manage that with a queue, keeping a most active. Yep, that's all we've got here. So good luck and keep on keeping on.